If you are starting organic chemistry and if you want to study the reaction intermediates like carbonium ions, carbocations, carbanions, carbons etc., their structure, formation, their stability and their reactivity, then these are the videos that you must see. Okay, so this is the right place where you have to see the videos. Okay, hi students, I am Priyanka Jain and you are watching the video of carbonium ion or carbocation. In this video, we will study about carbonium ion. And first of all, I want to tell you, if you want complete course of the chemistry, inorganic chemistry or organic chemistry or physical chemistry, then we have started our app, okay, where you can find all the types of PDFs, test series and courses in a in an efficient price. Okay, so you can visit our app and you can watch our different courses. First of all, understand what is the carbonium ion. Actually, carbonium ion refers to the ion, that is the ion with positive charge on carbon. It means there is a positive charge on the carbon atom. Okay, or we can say any organic species which has a carbon atom bearing the only 6 electrons in its outermost shell and has a positive charge on it, that is called a carbocation. Okay, means to say if we are taking a carbon atom to which 3 bonds are made, okay, suppose these are 3 hydrogen atoms, these 3 hydrogens are bonded. Now you know that the carbon can form 4 different bonds, but there are only 3 bonds. Okay, means to say there is a positive charge, it needs 1 electron. Okay, it is in the grid of 1 electron, so it will have 1 positive charge because 1 bond is remaining. Okay, so if this type of structure is formed, this is called the carbocation. Actually, there are two main types of the carbocations. One is called the classical carbonium ion. Classical carbonium ion means the normal type of carbonium ion that you see in your usual reactions. Actually, this is the carbon atom with the positive charge. Now this positive charge carbon has coordination number of 3. So whenever you see a carbon with a positive charge and 3 bonds, then this is definitely the classical carbonium ion. So it will look like this. See here, this is the structure. This is called tertiary butyl cation. This is tertiary butyl cation in which 3 CH3 groups are bonded to a carbon atom with a positive charge. The second type of the carbonium ion is called non-classical carbonium ion. Non-classical carbonium ion means that is not usual. Okay, in this case, actually what is happening, the positive carbon atom has a coordination number of 4 or 5. Actually, in this type of the carbonium ion, the positive charge has been localized over the different carbon atoms. Means to say, if you see non-bonded cation, this type of structure you see, and here is a positive charge. Okay, now this positive charge can localized over these different carbon atoms. Okay, so this is called non-classical carbonium ion. Now see the structure of the carbocation. Actually, the carbocation, the classical carbocation has planar geometry, or the carbon atom bearing the positive charge will have the trigonal planar structure. Why this is having trigonal planar structure? Actually, the carbon atom is sp2 hybridized, and you have studied the chemical bonding and you know that whenever the carbon atom will be sp2 hybridized or any atom is sp2 hybridized, then the structure will be trigonal planar. Okay, geometry will be trigonal planar. Now there are 3 bonding pairs of electron. sp2 hybridized means 3 sp2 hybrid orbitals are formed and there are 3 bonds. Okay, so all are bonding pair of electrons. Okay, so this is having a normal trigonal planar structure and the bond angle between the bonds will be of 120 degree each. Means to say, if this is the carbon and there are bonds in this manner. Okay, these are the 3 bonds. This will be in the form of trigonal planar structure and there will be a bond angle of 120 degree between them. This is the 120 degree angle. Okay. Now this species is highly reactive because our carbonium ion has a tendency to complete its octet of carbon. Now you can see that this carbon is having only the 6 electrons. Okay, and it wants to complete its octet. So these are highly reactive species. Okay, They can participate in many chemical reactions. Some of the reactions are unimolecular substitution reaction, decomposition of diazonium salt, elimination reaction, and various types of rearrangements. Now see the formation of carbocations. How the carbocations are formed. Actually, carbocations are formed by the heterolysis. It means uneven breaking of the bond. Okay. For example, it can be formed by the solvolysis of carbon and halogen bond. This X is halogen. CX bond means carbon to halogen bond can rupture. Okay, now you know that halogen will have the mole electronegativity. It means this bond will move in this manner. Okay, this is moving in this manner means this halogen is taking the electron with it. So now this R is having positive charge. So this is forming a carbocation. Similarly, deamination of amines by nitrous acid RNH2. When react with HNO2, it forms RN2 plus. Okay, with the elimination of water. So now this RN2 plus will leave out N2 and it is forming R plus carbocation. Third type of the formation may be by the reaction of halides with the superacids. Suppose you are taking this halide and you are treating it with SbF5. You know this SbF5 is a superacid. It is actually a fluoride acceptor. It has the tendency to take the fluorine. So it is forming R plus and SbF6. Okay. So in this way a carbocation is formed. And now fourth number. See, this is one of the most important type that you see in the usual reactions. That is protonation followed by dehydration of alcohol. If you protonate the alcohol, ROH is protonated, it forms ROH2 plus. Now this ROH2 plus will leave out the water. It means this bond will move in this manner. Okay. Means to say H2O is left out and you are getting R plus carbocation. This reaction you will see in your usual chemical reactions. I have told you several chemical reactions, several organic reaction mechanisms, and in some of which you have seen this reaction. Now the fifth type of reaction is the protonation of alkenes. This is also one of the important reaction. RCH double bond CH2. Okay, it is treated with H plus. It is protonated. So what is happening? This proton will move at this carbon atom. Okay, so you are getting a carbocation in this manner. Next is the protonation of carbonyl compounds. This is the third important reaction that you will see in your usual name reactions. Carbonyl compound is when protonated. What happens? You are getting a structure like this. Okay, soon this structure can resonance stabilize and it is forming C plus OH. Now this structure that you are seeing, COH, this one. Okay, this is called the carbocation. Now see the stability of the carbocations. Carbocation's stability is explained on the basis of inductive or resonance effect or by the hyperconjugation. See here, in carbocation I have told you there is a carbon atom and to which three bonds are attached. Okay, three bonds are attached and there is a positive charge. More the positive charge, less will be the stability of carbocation. And anything that can decrease this positive charge, any group or any effect, if it can decrease this electron density, it can remove this charge, then it is increasing the stability of carbocation. Means to say the stability of carbocation can be increased by decreasing the charge on this carbon atom. Just we have to decrease the charge on this particular carbon atom. Okay, so if you are decreasing the charge on this carbon atom, then you are increasing its stability. So means to say what you have to do, positive charge means deficiency of electrons. So if any group, suppose we are attaching a CH3 group here, this is the electron releasing group, so it will increase the electron density on this carbon atom because it is releasing the electrons. So the electron density on the carbon will increase. Okay, so the stability of the carbocation will also increase. Okay. So same thing I have written here, carbocation is electron deficient. Any group or effect which increases the electron density on it or reduces the positive charge will increase the stability. For example, alkyl group plus I effect. Alkyl group is electron releasing group. It means it is showing plus I effect. So it can increase the electron density. So it will increase the stability of the carbocation. Means to say tertiary carbocation will be most stable. See here why it will be most stable. See, suppose here I have taken this. This is a methyl radical. 3 hydrogens are attached to it and there is a positive charge. This will be least stable. But suppose I am taking here a CH3 group. Okay. So what is happening? This CH3 group will donate the electron density. It means there will be this effect plus inductive effect. Electron density is being increased on the carbon atom. So the stability of carbocation is increasing. So this carbocation is much more stable. Okay, then see the next one. If we are increasing one more methyl group, okay, one more alkyl group we have increased here, then again what is happening, we are getting the electron density from two places. Okay, means to say this positive charge is now having lesser effect. This positive charge has been decreased because electron density has been increased, so this will have more stability. Similarly, if I am making here tertiary butyl group, this is the tertiary butyl group when 3 CH3 are attached to a carbon atom. Okay, now there is a positive charge, but what is happening from here, from here, from here? Electron density is provided to this carbon atom. Okay, due to their electron releasing effect, there is more electron density. So the effect of this negative charge has been decreased. Means to say this carbocation will be most stable out of these four. Okay. Similarly, if you have given any allyl group or benzyl group, these groups can stabilize the carbocation by resonance because these are having double bond. Okay, so they can undergo resonance. Means to say these are stabilizing the positive charge, so they provide more stability. Okay, so we can say that these allyl groups or benzyl groups, if these are present, then they will be more stable. So what we can say, if we want to make an order of the stability of the carbocations, then how we will make? See here, CH3, this carbocation will be least stable as we have seen. Then CH3, CH2, then CH3, C, CH3 plus this will be more stable. Then CH3, C, CH3, CH3 plus group. Okay, this is tertiary butyl cation. This is called isopropyl cation. And these you know, these are ethyl cation. And this is methyl cation. And then you can write for the stability will be more in the case of CH2 double bond CH, CH2. Then will be for C6H5 CH2 radical. This is called benzyl cation. And this one is called allyl cation. And more will be for C6H5 whole thrice C plus. This is called triphenyl methyl cation. And then most stability will be for tropylium cation. So this is whole about the carbonium ion. I hope you like this video, and if you are liking my videos, please like these videos, share these videos and subscribe the channel. And if you want to see more PDFs, then these videos PDFs are available on my Telegram channel. So link of Telegram channel is given in the description box and also in the description box of the whole channel. Okay, so you can see the Telegram channel and then subscribe that channel and you can find the free PDFs. Okay, and for the courses you can go to our app. So meet you in the next video. Thank you.